Hi, I'm Santi from Inpronic USA. In this tutorial, we're going to look at the difference in data delivery between a 2024 vehicle and a 2012 vehicle. For context, it's important to understand that in OBD-II, vehicles from the 1990 and early 2000, many control units would broadcast data continuously. That means as soon as you connected them to the trainer or a scanner, you could already see RPM, speed, temperature, or voltage without sending any request. The change in 2008, with the ISO 15765 standard for CAN, mandatory in the US since January 2008, all vehicles moved to a formal request response format. From that point on, there were no more automatic data broadcasts you now have to query with a specific PID for the car to respond. Between 2010 and 2016, many manufacturers migrated to more advanced protocols, such as UDS, ISO 14229. Here, broadcast never exists, everything is request-based, and some functions even require extra security with access keys. The era of cybersecurity from 2018 onward, with standards such as UNIS R155 and ISO SAE 21434, several manufacturers began adding secure gateways or firewalls in their vehicles. This means that even if you connect a scanner, some data is blocked until you authenticate. Now that you have the context, let's get started with the tutorial. First, we start the modern vehicle. Once we locate the OBD-II port, we connect the OBD-II cable, and the other end goes directly to the trainer. We then connect the trainer to the computer using a USB cable. The LED strip powers on, and LED 7 begins flashing slowly, confirming a successful connection. We open our software and select the COM port, in this case, COM3. The protocol is OBD-II, with a speed of 500 kilobits per second. We press start, and LED 7 will begin flashing rapidly. As we explained at the beginning, when the connection starts, no data is transmitted at all, because we are connecting to a 2024 Nissan Kicks. To obtain information, we must make a specific request, and that is exactly what we are going to learn. We go to our mode table, where we see that mode 01 shows the available parameters. In this case, we are going to request the engine RPM, and we find that the PID for this is 0C. We go back to our software and verify that the ID is 7DF. Now we are going to make the request. 0x02 is the number of valid bytes. 0x01 is the request for available parameters. We change this byte to 0x0C in order to receive the RPM. We press CAN TX, and immediately we get a positive response at the bottom. In byte 3, we verify that it is the reply to 0C, and in bytes 4 and 5, we obtain the response in hexadecimal. Let's calculate the engine RPM. The formula is 256 multiplied for A more B divided by 4. The prefix 0x means that the number is in base 16, or hexadecimal. To convert it into base 10, or decimal, each hexadecimal digit ranges from 0 to 15, that is, 0 through 9, and A through F, where A equals 10, B equals 11, up to F, which equals 15. Each digit is multiplied by a power of 16, depending on its position, as we can see in the example. With the data obtained, we now apply the formula step by step, reaching a result of 650 revolutions per minute in this case, with the Nissan Kicks. Now we are going to obtain the vehicle speed. For that, the PID is 0D. We change the 0x0C in our data field to 0x0D. Press CAN TX, and once again we receive a positive response. In this case, the bit 4 shows 0x00 because the vehicle is not in motion. The last request will be the throttle position. For this, we see that the PID is 11. We enter 0x11 and press CAN TX, once again obtaining an immediate response to this request. If we request the information while pressing the accelerator, the response will vary compared to the first request when the vehicle was static. Now let's calculate the throttle pressure. The formula is A divided by 2.55. The prefix 0x means the number is in base 16, or hexadecimal. To convert it into decimal, each digit is multiplied by a power of 16 according to its position. In this case, 0x16 equals 22. When we divide 22 by 2.55, we get 8.63. That means the throttle pressure is 8.63% in this Nissan Kicks. Now, we are going to test with a 2012 vehicle. First, we start the vehicle and perform the same connection process. One end to the OBD-II port, and the other end directly to the trainer. Through a USB cable connected to the computer, the LED strip powers on, and LED 7 begins flashing slowly. We select our port and open it, then choose the OBD-II protocol with a speed of 500 kilobits per second. When we press start, we can immediately see the difference. In this Ford Escape 2012, the information appears on its own. The data keeps flowing uncontrollably. To obtain the same data as with the modern vehicle, we need to filter this information. We check the ID box and verify that the value is 7E8. We go to the transmission section and remember that the request ID is 7DF. In this case, we are going to request the engine RPM. So we enter 0x, 0c, press CAN, TX, and immediately we get a positive response in the last row of the receiver. Applying the same formula, the prefix 0x means the number is in base 16, or hexadecimal. In this case, bit 4 has the value 0x0a, which equals 10 in decimal. Bit 5 has the value 0xb2, which equals 178 in decimal. Now we apply the formula step by step. 256 times 10 equals 2,560. Adding 178 gives us 2,738. Finally, dividing by 4 gives us 684.5. So the engine speed is about 685 RPM. Now we are going to request the vehicle speed by entering 0x0d. We press CAN TX, and likewise, the response appears at the bottom. The value is 0x14 because the vehicle now is in motion. To calculate the vehicle speed from the value in byte 4 equals 0x14, we use the standard formula for PID 0x0d. We convert it to decimal and then interpret the result. In this case, the speed is 20 kilometers per hour. The last request is for the throttle position, 0x11. We press CAN TX, and the response is displayed. Finally, we calculate the position of the accelerator. The formula is A divided by 2.55. In this case, bit 4 has the value 0x24. The prefix 0x means the number is in base 16. We convert it to decimal by multiplying 2 times 16 plus 4, which equals 36. Now we apply the formula. 36 divided by 2.55 equals 14.1. So the throttle pressure is about 14.1% in this vehicle. Thank you very much for watching this video, and remember to follow us for more tutorials.